In this video, we're going to be simplifying nth roots. In 1, it wants us to write each of the following as perfect squares, and the example they give is 100x to the 14th is equal to 10x to the 7th squared. And if you notice that 14 divided by 2 is equal to 7. So that will help us know how many factors to put inside the parentheses when we're working on these problems, the perfect cube and the perfect fourth. We can use the same technique all around. So for x is equal to 60 and we want to write it as a perfect square, then we're going to write this as 60 over 2 is equal to 30. So we're going to have x to the 30th squared. In b, we have 1 over 81 times x to the 12th, y to the 24th, and we're going to have 1 over, if we were to take the square root of 81, we would get 9, and now 12 divided by 2 is 6, so we're going to have x to the 6th, and 24 divided by 2 is 12, y to the 12th, all squared. And 2, we want to write each of the following as perfect cubes. And the example they give is 8x to the 6th is equal to 2x squared cubed. And 6 divided by 3 gave us 2 for our exponent. And the cube root of 8 is equal to 2. So in A, we have x to the 60th, and 60 divided by 3 is equal to 20. So we're going to have x to the 20th cubed. In B, we have negative 27 over 64 times x to the 12th, y to the 24th, and this is going to be equal to, the cube root of negative 27 is negative 3. The cube root of 64 is 4. And then 12 divided by 3 is equal to 4, so we're going to have x to the 4th. 24 divided by 3 is equal to 8, so we're going to have y to the 8th, all cubed. And 3, we want write each of the following as perfect fourth powers. The example they give is x to the 12th is equal to x cubed to the fourth power. And 12 divided by 4 gave us our 3. So in A, we have x to the 60th, and that's going to be equal to 60 divided by 4 is equal to 15. So we're going to have x to the 15th to the fourth power. In B, we have x plus 1 to the 4th times 9x to the 8th, y to the 4th, all squared. So the first thing that I'm going to do, square all of the factors inside the parentheses that has 9x to the 8th, y to the 4th. So I'm going to say that this is equal to x plus 1 to the 4th times 9 squared is equal to 81. X to the 8th squared is x to the 16th, and y to the 4th squared is y to the 8th. And now we can write it as x plus 1 to the 4th, and now 81 is equal to 3 to the 4th power, so we could say 3. 16 divided by 4 is equal to 4, x to the 4th. 8 divided by 4 is 2, so we could write this as y to the 2nd, all to the 4th power. And now we can say that this is equal to x plus 1 times 3x to the 4th, y squared, all to the 4th power. In 4, they want us to write each of the following as a perfect nth power. And in A, we have x raised to the 60n, and if we divided 60n divided by n, we'd get 60. So we could say this is equal to x to the 60th to the nth power. In B, we have a raised to the 2n divided by b raised to the 3n times b raised to the 4n. And the first thing that we could do is combine our factors in the denominator. So we have a to the 2n divided by b to the 7n. And if we were to divide 2n by n, we would get 2. So this is equal to a squared over Now if we were to divide 7n divided by n, we would get 7, so we'll have b to the 7th, all raised to the nth power. In 5, it says, simplify the expressions below by completing each step. Use absolute value signs where necessary. In A, we have the cube root of negative 64, x to the 6th, y to the 6th. And they want us to rewrite the radicand as a perfect third power. So we're going to have the cube root of negative 4, x squared, y squared, cubed. And now we have the cube root of something we're also cubing. So the radical is going to go away, and this is equal to negative 4 x squared y squared. In B, we have the sixth root of 128 x to the 12th y to the 12th divided by 2 x to the 18th y to the 6th. And the first thing they want us to do is simplify the radicand using laws of exponents. So we're going to have the sixth root of 128 divided by 2 is equal to 64. X to the 12th divided by x to the 18th is x to the negative 6, so it becomes x to the 6th in the denominator. And y to the 12th divided by y to the 6th is equal to y to the 6th. And now they want us to rewrite the radicand as a perfect sixth power. So this is equal to the sixth root of 64 is 2. And we have 6 factors of y, so we're going to have 1 factor of y and x. And this is all raised to the sixth power. And now they want us to apply the definition. So this is equal to the absolute value of 2y divided by x. Now we have an even root, so we need to make sure that we take the absolute value. In C, we have the fifth root of negative 27 x to the 6th y squared times 3x squared y to the 4th squared. They want us to simplify the radicand using laws of exponents, so we can say that this is equal to the fifth root of negative 27 x to the 6th y squared times 3 squared is 9, x squared squared is x to the 4th, and y to the 4th squared is y to the 8th. And now we can multiply the sets of parentheses times each other. So we have the fifth root of negative 27 times 9 is negative 243. X to the 6th times x to the 4th is x to the 10th. Y squared times y to the 8th is y to the 10th. And now they want us to rewrite the radicand as a perfect fifth power. So we're going to have the fifth root of negative 243 could be written as negative 3 to the 5th. So we're going to have negative 3 x squared y squared raised to the 5th power. And now we're going to apply the definition, and the fifth root of negative 3x squared y squared to the 5th power is equal to negative 3x squared y squared. And that's our video on simplifying the nth roots, part 2.